This section is on hypothesis testing using rejection regions. So this is an alternative to using the p-values. A rejection region, which is sometimes called the critical region of the sampling distribution, is the range of values for which the null hypothesis is not probable. If a standardized test statistic falls within this region, this is statistically significant, and we reject the null hypothesis. The critical value z0 separates the rejection region from the non-rejection region. So we still have three types of tests: the left tail test, the right tail test, and the two-tail test. And they are determined by the alternative hypothesis. So if the alternative hypothesis uses a less than sign, it's left-tailed. If it uses a greater than sign, it's right-tailed. And if it uses a not equal sign, it's two-tailed. Now, to make the rejection region, we need to know the critical value, and that is found on this table. So here are the steps. First, we need to determine whether the test is left-tailed, right-tailed, or two-tailed. Then we need to use the table to find the critical value, z0, for the level of significance, alpha. Next, we want to sketch the standard normal distribution and draw a vertical line at the critical value, and then shade the rejection region. Then we need to calculate the standardized test statistic z. Now for the decision, we want to compare the standardized test statistic z with the rejection region. So if z is in the rejection region, then we reject the null hypothesis. If z is not in the rejection region, then we fail to reject the null hypothesis. On number 1, z0 is negative 1.28. So this is our rejection region. Z is negative 0.46. So z is not in the rejection region. So we fail to reject the null hypothesis. On question 2, z0 is still equal to negative 1.28. So we have the same rejection region. However, this time z is equal to negative 1.72. So z is in the rejection region, which means we want to reject the null hypothesis.